Many people wonder why we can't hear sounds in outer space, even though we see intense scenes in sci-fi movies. The truth is, sound needs a physical medium to travel through, while space is almost a total vacuum. We're going to dive into how sound actually works scientifically, and why we sometimes hear sounds from planets and stars after they've been processed by computers, along with some mind-blowing facts about the precise design of our universe. Sound is really just vibrations traveling through molecules in the air, water, or solid stuff. For example, when you ring a bell, its movement pushes the nearby air molecules, which then set off a chain reaction that carries those vibrations all the way to your ears. But in space, the distances between particles are so massive that vibrations just don't have a way to travel. The air density in space is actually less than a trillionth of what we have here on Earth. That's exactly why astronauts can't just talk to each other directly outside their spacecraft. They have to use communication gear that turns their voices into radio waves, which can travel through the vacuum of space without any problem. If the sun were to suddenly explode, we wouldn't hear a single thing. We'd see the flash of light about 8 minutes later, but the sound would never reach us because there's absolutely no air to carry it across the distance between us and the sun. So how do we hear sounds from planets like Jupiter or Saturn in some videos? The truth is, those aren't actual sounds but a conversion of radio waves emitted by those celestial bodies. Planets and stars blast out radio waves because of their super powerful magnetic fields. For instance, Jupiter's magnetic field is actually 20 times stronger than Earth's, and it pumps out all kinds of different energy. Stellar winds and plasma around stars also produce natural vibrations. Plasma is made of charged particles that interact with magnetic fields, creating frequencies that can actually be recorded. Then, scientists take those radio frequencies and turn them into sound signals we can actually understand using a computer. The process is pretty much like translating from one language to another, but it is incredibly precise. If you compare this to what happens in your own ear, your ear turns air vibrations into nerve signals. Scientists are basically doing the same thing. They turn space radio waves into air vibrations that we can actually hear. For example, scientists listened to the sound of Saturn's rings after converting their radio waves. The result was these complex sounds that remind us of ocean waves, reflecting how charged particles interact with the magnetic field. If you look at the precision of this cosmic system, you find that every celestial body has its own unique acoustic fingerprint. For example, Earth's converted sound is totally different from the sound of Mars, because of the differences in their magnetic fields and their atmospheres. So the design of this universe is based on airtight physical laws that never clash with one another. The vacuum of space is not a flaw. It is actually a necessity for planets and light to move around without any obstacles, and it also protects them from destructive noise. And the fact that there are radio waves we can actually turn into sound is absolutely mind-blowing. Honestly, if those waves did not exist, we would never have been able to study so many of these cosmic phenomena, and we would have had no idea just how active those far-off celestial bodies really are. So this really helps us realize that what we think is silence in space is actually a world packed with all kinds of different signals. The sound we can hear is just a tiny piece of everything that can be measured, and the precision of this whole system shows up in every single detail, no matter how small or large it is.